Okay, today we're going to go over rational expressions. We're going to be doing the first half of the section where we're going to simplify rational expressions. We're going to multiply and divide. And we're also going to talk about the excluded values. Now, as you know, the bottom of a fraction cannot equal 0. So we always have to specify which numbers the fraction cannot equal, the variables in the fraction cannot equal. So I look at the denominator here and I say, well, what number could I put for x that would make the denominator equal to 0? The answer is 2. So we're going to write x cannot equal 2. X equals 2 is excluded from the denominator. Over here, we have a denominator of x squared minus 1. So in order to find out what values are not allowed, I have to make x squared minus 1 equal to 0 and solve. X squared minus 1 can be factored. X plus 1, x minus 1. And when I solve this, I do the zero product property. X plus 1 equals 0, or x minus 1 equals 0. When you have a product equaling 0, one of the factors must equal 0. This one becomes negative 1. This becomes 1. My excluded values are positive and negative 1. Can you give me a thumbs up, thumbs down, thumbs sideways that you understand this first topic? One big, two big thumbs up, sideways. Okay. Try putting 2 into the bottom of this fraction. We're going to get 4 divided by 2 minus 2, which is 4 divided by 0. If you do that on your calculator, you're going to get an error. So that means 2 cannot be part of this function. It's not part of the domain. Okay? We're going to have an asymptote or a whole or something else, but 2 is not defined in this fraction. Let me give you one to try on your own. What about 5 over 2x plus 1? What value of x cannot be part of this domain, the domain for this rational expression? Well, make the bottom equal to 0. 2x plus 1 equals 0, and solve it. Minus 1, 2x equals negative 1. Divide by 2, and I can see that x equals negative 1/2 is the value. That makes this denominator equal to 0. So I'm going to say x cannot equal negative 1/2. Over here, the reason we did all this strange stuff is because we had a quadratic. When you have a quadratic in your denominator, you have to use quadratic methods to solve it. I use this factoring in the zero product property. You could use quadratic formula as well. Okay. Be sure your microphone is muted. I have one of you with your microphone still on right now. So check your mics real quick. Thank you. And we're going to go on. Simplifying rational expressions. Okay. A rational expression is not simplified until the greatest factor between the numerator and denominator is 1 or negative 1. Okay. So all you have to do is factor and cancel. I look at the top here, and I'm going to do the same thing we've been doing on our worksheet today. I'm going to factor out the lowest power out of these two. And that's going to be x squared. When I divide this by x squared, I say x squared times what equals x cubed? The answer is x. X squared times what equals x squared? The answer is 1. I can see now that I have an x plus 1 on top and an x plus 1 on the bottom. Cancel them out. And I have simplified this to x squared. There's only one problem, though. We have to state all the excluded values like we did up above. So what number makes the denominator equal to 0? Well, I can see that -1 cannot be in for x, or you'll make the bottom 0. So x cannot equal -1. Thumbs up, thumbs down, thumbs sideways on that one? Okay, seeing thumbs up. Okay. The second one here is going to be like the second one earlier. First, let's factor the top and the bottom. For the top, you could do a diamond problem, the big X, and you're going to have 6 and 5. 1 and 5 multiply to, they don't multiply to 6. How about 2 and 3? 2 and 3 multiply to 6 and add to, I put the numbers backwards. I was looking down below. I'll tell you in a second. Okay, start over. A times C goes on top. B goes on the bottom. There we go. What multiplies to 5 and adds to 6? 1 and 5. So we get x plus 1, x plus 5 on top. On the bottom, I can factor that to x minus 5, x plus 5. The x plus 5s cancel out, and we're left with x plus 1 over x minus 5. I have to look back right here to see what values x cannot be. I need to know what makes each one of these equal to 0. So x cannot equal 5, and x cannot equal -5.
Can you move it down a little bit?
Like that?
Yes.
Okay. So let me review what we did. The x plus 5s cancel out, leaving you with x plus 1 over x minus 5. I have to look back at my original problems before canceling to see what x can't equal. I can't just look here because I have to look at what canceled out. So x cannot be -5 and it cannot be 5. I think I'm going to have you guys do one example of this. Let me get one right now. Okay. Everyone try this one. X cubed plus 3x squared over x plus 3. Simplify this one right here. I'm going to give you one moment. Factor the top, factor the bottom, cancel, and state the excluded values. What do you get when you factor the top? Kennedy, what do you get? Go ahead.
I got x squared times 1 plus 3.
X squared times
1 plus 3.
That's very close. X squared times something equals x cubed. X squared times what? X. Very good. And you know what? You can see they made the problem nice like this so that the x plus 3s would cancel out. Final answer is x squared. What is the excluded value? What's the excluded value? Anyone?
-3.
-3. X cannot equal -3 because that's going to make the denominator equal to 0. Thumbs up, thumbs down, thumbs sideways. Do you understand how to do these? I need a response from everyone. Thumbs up, thumbs down, thumbs sideways, okay. Mostly thumbs up, 1 or 2 thumbs sideways, okay? Good. Let's multiply. Multiplying is just an extension of what we just did. All you have to do is factor 4 things instead of 2. This is how the last problem was. It's just one fraction. Well, now you have an additional fraction. It's not that big of a deal. Unless the last one was. Here, I'm going to factor my x squared minus 1. It's the difference of 2 squares. Here, I can see a 3 comes out. Factor out a 3, and you have x minus 7. Now, right here is where I decide what my excluded values are. Before I cancel, I can see that x cannot equal 1 and x cannot equal 7. I'm going to write that over here just for my notes. X cannot be 1 or 7, and I'll put that on my final answer. Look here, x minus 1. Everyone look at this. Look right here. X minus 1, x minus 1. They cancel. X minus 7, x minus 7. They cancel. What I'm left with is x plus 1 over 3, and x cannot be 1 or 7. I should probably put this in a set. It cannot be one of those two. Any questions? Let me do the next one for you. Okay. I can factor the bottom here. And I get x plus 2, x minus 2. I hope you're seeing that it pays to get really good at factoring. Look here. I'm going to factor the top. I'm going to use the diamond problem, and I'm going to get x minus 3, x plus 2. On the bottom, I'm also going to use the diamond. I'm going to scratch paper. I'm going to get x plus 3, x plus 3. Once again, I look here to see what my excluded values are. X can't be 2, x can't be negative 2, and it can't be negative 3. Let's begin to cancel. I have an x plus 3 canceling with an x plus 3, but these two do not cancel. One of them's a plus, one's a minus. Don't cancel them. I have an x plus 2 canceling with an x plus 2, and I think that's it. On top, I'm left with x minus 3. On the bottom, I have 2 factors. X minus 2 times x plus 3. And my x cannot equal 2. X cannot equal negative 2. And x cannot equal negative 3. I'm writing it out like this because that's how the book does. I want to take a screenshot of that one so we can finish up the last problem.
Are you posting this?
I will post this video online in about 30 minutes.
Okay.
Okay. So let me do the last part. Maybe it'll pay for you to just, it'll be better if you just watch me do this rather than trying to copy as fast as you can. So let's see how we do a division problem. To do a division problem, we always know that we flip the number or the fraction after the division sign. First, I'm going to factor though. Factoring this one using the diamond problem, we're going to get x minus 1 over, sorry, let me scoot this up. X minus 1, x minus 1. On the bottom, I have an x in common. And I'm going to be left with x squared plus 1. Over here, factoring the top, I get x plus 2, x minus 1. On the bottom, I get 3, x squared plus 1. You can go and verify these factorings. It's just like our previous homeworks. Now I'm going to take this and flip it. Okay? And I'm going to get then rewriting the first one, x minus 1 over x squared plus 1. Over here, to multiply now, I'm going to put this on top. 3 x squared plus 1 all over x plus 2, x minus 1. Now, look at your excluded values. Here, x cannot be 0. Here, there's nothing that will come out of this. There's no number squared plus 1 that equals 0. Here, x cannot be -2, and x cannot be 1. The only problem here is we have to look back at this beginning denominator right here, and we have to see, well, does anything make that 0 also? The answer is no. You could check it by going on Desmos and putting this in, put y equals 3x squared plus 3, and see where it hits the x-axis. If it doesn't touch the x-axis, then there is no 0. So these are my numbers that are excluded. Let's start canceling. I have an x squared plus 1. I have an x minus 1. On top, I'm left with 3, x minus 1. I have a 3 here and an x minus 1. Down here, I have an x and an x plus 2. And my excluded values are 0, -2, and 1. Everyone, these are a little bit complicated. You're actually going to have to put in the time to keep on factoring and keep remembering your excluded values. But once you do this a lot, it gets really much easier and very fast. But when you're just beginning to do these, and if you haven't done these a lot, it can take a while. Okay? So give me a moment to stop the video here.